We said in the last video that if we have absolute extrema, they must occur either at critical numbers or at the endpoints of a closed interval, one of those two possibilities. And we can use this theorem, this idea, to help us find absolute extrema on a closed interval. So here we'll look at the absolute extrema of f of x equals x cubed minus 12x over a few different intervals. And we just said we want to find the the absolute extrema. They either occur at critical numbers or at the endpoints. Well, if I look at just part A right here, I have the endpoints of my interval. I just need to go find the critical numbers now, and then I can just test all of the critical numbers that I have along with the endpoints. So I'm going to start by finding the critical numbers, which means I need the derivative. So f prime of x is equal to 3x squared minus 12. If I want to find critical points, I want to take my derivative, set it equal to 0. I have 3x squared minus 12 is equal to 0. Solving this gives me 3x squared equals 12. X squared equals 4, which means x equals plus or minus 2. So here are two critical numbers that I have. I also just want to double check. Remember, critical numbers also occur where the derivative does not exist. Here in this case, though, if we look at the derivative, we have a polynomial, so we know that that derivative exists everywhere, which means there's not going to be any additional critical numbers. All we have are positive 2 and negative 2. So let's think just for a second about what we're trying to find here. We want to find the absolute extrema. And really what that means, I want to find the absolute maximum and the absolute minimum. We said in the last video that the absolute maximum and the absolute minimum were the highest y value and the lowest y value. Those are the two things that I'm looking for. So I need to go and find the highest y value and the lowest y value. I have four possibilities where they could be. They could be at the endpoints of my interval, so negative 5 or positive 5, or negative 2 and positive 2. So I really only have four places to check, which is nice. It's a very manageable number. I'm going to take each of those four numbers and find the y values that correspond to those x values. And to find the y values, I'm looking at my original function f of x. So I'm going to take negative 5, positive 5, negative 2, positive 2, and plug them into my function f of x, because that would tell me the y value, and then I just need to pick the highest and the lowest one. So let's just get right to it. I'm going to start with my critical numbers here, so I'm going to take negative 2 and plug it into my function. Negative 2 to the third power minus 12 times negative 2, and here we have a little bit of number crunching here to do. We end up with a positive 16 though. And then I'll do the same thing with positive 2. So I'll say f of positive 2, 2 to the third minus 12 times 2. This time I end up with a negative 16. So I've tested the critical points, which is good, but I also want to test the endpoints of my interval. Don't forget about those. So I'm going to take negative 5 and positive 5, plug those into my function f of x. So f of negative 5 here, I have negative 5 to the third minus 12 times negative 5. We'll plug that into our function, and we end up with negative 65 here. And f of positive 5, I have 5 to the third minus 12 times 5. This time I end up with a positive 65. So really what I want to do now, when we talk about absolute extrema, we're looking at the x values, or excuse me, the y values. We're looking at the y values, which are what I just found. So I want to look at those, and I want to pick, well, what's the highest, what's the lowest? The highest is this guy right here, f of 5 equals 65. So that means that 65 is my absolute maximum. And that means that the lowest y value right here is negative 65. That is my absolute minimum. So we can write our answer in a couple different ways. We might say our absolute maximum. I believe the way the textbook formats their answers, the way my math lab formats their answers, they'll say f of 5 equals 65. And again, that's just because 65 was the highest y value that we came up with. For me, I don't mind if you give that as an ordered pair. So if you said 5 comma 65, I think that's just fine as well. But my math lab, what it's going to be looking for is the y value of 65. This f of 5 is just describing where that absolute maximum occurs. My absolute minimum then, the lowest y value, we said that was negative 65. So f of negative 5, is equal to negative 65 or negative 5 comma negative 65. Either one of those will be just fine here. So that is my absolute maximum and my absolute minimum on this particular interval, negative 5 to positive 5. Now, if I change the endpoints of my interval, so now if I restrict my interval a little bit, now I'm looking at, say, negative 3 to positive 3, my absolute extrema might not be the same. And actually, if I look, we said the absolute extrema occurred for this particular interval at negative 5 and positive 5. We know that's not going to be the case here, negative 3 to positive 3, because negative 5 and positive 5 are not in that interval. They're not between negative 3 and positive 3. If we have to test multiple intervals, it's kind of nice because we actually have done a lot of the work already. So you would go and find your critical points, but we already did that. We're working with the same exact function. We're just changing our interval. So our critical points are positive 2 and negative 2. So we would like to test those along with our endpoints in our original function. So what did we say? We said f of negative 2, that was equal to 16. F of positive 2, that was equal to negative 16. I'm just now going to take the two endpoints that I'm looking at, which are negative 3 and positive 3, and plug those into my function as well. One thing that I haven't mentioned here, be careful. Make sure that you're plugging those into your function f of x and not your derivative. It's a really common mistake to make, and I see it all the time. It's really easy to make that mistake. Remember, we're looking for the y value, so we're looking at f of x, not f prime of x. So if we look at f of negative 3 and plug that into our function, we should end up with a positive 9. And then if I take positive 3 and plug that into my function, this time I end up with a negative 9. So I want to pick the highest y value and the lowest y value. Well, the highest y value, is 16. So 16 is my absolute maximum. It occurs at negative 2. And my lowest y value is negative 16. That occurs at positive 2. So if I wanted to summarize this problem, I have an absolute max at f of negative 2 equals 16, and an absolute minimum at f of 2 equals negative 16. One last interval that I'd like to look at here, and this one's a little bit different, so I want to make sure that we have some time, even though I'm running out of room here. The next interval that we're going to look at is negative 3 to positive 1. So what makes this interval different? We're working on negative 3 to positive 1. So we said our critical points, we said those were x equals plus or minus 2, so 2 and negative 2. Look at our interval, negative 3 to positive 1. What's the problem here? It's that negative 3, I'm only counting numbers between negative 3 and positive 1, only x values between negative 3 and positive 1. 2, x equals 2, is not between negative 3 and positive 1, which means for the purposes of this problem, I'm basically going to pretend like it's not a critical point. It's not a possibility for my local extreme value because it's, or excuse me, for my absolute extreme value because it's not in our interval. So I will take -2, -3, 1, and plug those all into my function. So f of -3, we said that was 9. And actually here, let me do this in a different color just so that it stands out. F of -3, we said that was 9. F of -2, we said that was 16. And f of 1, this time I've got to look at it, and 1 would give me -11. So f of -2, this is my absolute max, equals 16, that is my absolute max. And f of 1 equals -11, this is my absolute minimum. So be careful. It's something I kind of glossed over here at the beginning, but be careful that when you find your critical points, make sure that they fall within your interval. All of the other intervals that we worked with in A and B, -2 and +2, those were both in those intervals. They were both between -5 and +5, and they were both between -3 and +3. But if we have an interval where one of our critical points doesn't fall into that interval, we basically just say, you know what, we're going to ignore that because it's not in our interval. So we basically just pretend like that critical point doesn't even exist. So again, this is how we're going to find absolute extrema. You're finding your critical points, you're testing your critical points and your endpoints with the original function f of x or g of x, and then you're picking out the highest y value and the lowest y value.